Today is the 23rd of February 2024. Yesterday we started looking at the histogram. So we look at the introduction and I solved the question and I showed you how a histogram would look like. Okay. Now, thank you everyone who has subscribed, who is sharing, liking, following us. I appreciate it a lot. Okay. If you haven't done so already, can you consider subscribing, please? Thank you. And if the account is not yours, ask permission from the account holder. It's very important. Okay. And or ask somebody to help you open your account, and then you use that to subscribe. In the comment section, you normally see please follow my notes / script. Okay, so for instance, this is 10 to the power 5 and that's 10 to the power 6. Okay, so if you hear anything apart from what is on the notes, please go by the notes. Okay, beware of scammers. Okay, there is a lot of scammers, new scammers, old scammers. They have improved their skills. Beware. Okay, if I want donation for an orphanage, I'll tell you in the video. If I want donation for amputees, seriously ill people, I'll tell you in the video. Actually, this platform is not even being used for that. Okay, so just beware. If you've not heard it from me, like I'm telling you now, don't assume. Okay, and if somebody send you a friend request, it's not me. Okay, so don't say that, oh, I've sent you a friend request and you start chatting thinking you are chatting with me. It's not me, please. Recap. We started looking at histogram. Okay, we did an intro. Okay, and I showed you why there is a need to plot a histogram. Okay, when you can do an archive, a cumulative frequency curve. Watch last video for recap. Normally when you are starting a topic in math, the introduction is very important because it's like dominoes. If you don't understand the introduction and you just think, oh, I'll get to the complex one, at times you might be muddled up. So if you understand the basis of that topic, at times even without knowing a lot, okay, you can use that to solve questions, especially if it is asking you simple questions. You can just realize, and through that knowledge you can build on that to solve complex questions. Okay, all right then, please watch last video for recap. It to help you. Now I started for today. We've looked at this question, okay, and I want to revisit it. We look at it on a starter and I gave you 2 methods, but at times when I go away I think about how to make it easy for you to understand, and also the simplest way I can solve it so that you can learn that. Okay, or maybe you know one way and I've also introduced another way, but if you know how to solve it, then depending on your level Okay, so even though this is a higher paper, it's still fairly easy. Okay, so if you can solve it in a way that a student in a foundation group will solve it, then it means that they might decide to do a higher paper and get a higher grade. Okay. So I'm going to revisit it again. The first two methods I've written it out, and then the third one I'm going to show you how to I reason that out. Okay, so please let's get on. So we have 2 times 2.3 times 10 to the power 6, okay, minus 3 times 10 to the power 5. Now, using board mass here, times come before subtraction, okay? So, what they are telling us here is all this 2.3 times 10 to the power 6 and then 3 times 10 to the power 5. Okay. Now look at it carefully again. The first one we did, I showed you 10 to the power 6. So between 2.6, we've done video on this. You move, because the 6 is positive, you move the decimal 6 times to the right. So the decimal is here. Okay, we are here. Okay, so 1, 2, 3, 4, 5, 6. So if I put all the zeros in there, I have 2.3 million. 3 times 10 to the power 5. So 3, 1, 2, 3, 4, 5. Because it's 10 to the power 5. So now I have 1, 2, 3, comma 1, 2, 3. So 300,000. So what it means is 2.3 times 10 to the power 6, which is 2.3 million, minus 3 times 10 to the power 5, which is 300,000. Now when you subtract, okay, it's a non-calculator paper, you get 2 million. So now 1, 2, 3, 4, 5, 6. We are leaving our answer in the standard form. So it's 2.0, okay, times 10 to the power 6. That will be our answer, which we did in the last one. The second method we look at is, instead of 2.3 to the power 6, we had 23 times 10 to the power 5, because we can write this as 2.3 times 10 to the power 1 times 10 to the power 5. Okay, because 10 to the power 1 times 10 to the power 5 will give us 10 to the power 6. So 10 to the power 1, which is 10, times 2.3 becomes 23. So now we have 10 to the power 5 minus 3 times 10 to the power 5, because we want to have the 10 to the power 5. Okay, so now we have 23 minus 3, then 10 to the power 5 there. So 23 minus 3 will be equal to 20 in the bracket times 10 to the power 5. So now 20 to the power 5. Okay, now if we add 5 zeros, we have 2 million, which will become, or 20 is the same as 2 times 10 times 10 to the power 1 times 10 to the power 5. So 10 to the power 5 times 10 to the power 1 will give you 10 to the power 6. Okay, if the 20 becomes a 2. So 2.0 times 10 to the power 6. Okay, now this is wrong because it said 20 times 10 to the power 5 is wrong because it said leave your answer in the standard form. So this is the standard form. That is not a standard form. Okay, so you need to leave your answer in standard form to get the final marks. Now the third method I was thinking of, okay, now if you have, look in this box, if you have 20 minus 30 equals 10, but 30 can be written as 3 times 10. 20 also can be written as 2 times 10. Okay, so now if I bring the 10 out, I have 3 minus 2. So now I have 10 times 1, which is equal to 10. So 30 minus 20 equals 10. We know that, but I've just used indices to solve that or prove that for you. Okay, so with this knowledge, 2.3 times 10 to the power 6 minus 3 times 10 to the power 5. 2.3 becomes 23 times 10 to the power 5 minus 3 times 10 to the power 5. Okay, now look at these two equations. I can use factors to bring 10 to the power 5 is common here, is common here. So if I bring 10 to the power 5 out, I have 23 minus 3. Okay, so now I have 10 to the power 5, 23 minus 3. Okay, so which is in the bracket is 20. Now 20 times 10 to the power 5. So it means I'll add 5 zeros to 20. If I add 5 zeros to 20, move 5 0 to 20, I have 2 million. Again, in the standard form, is 2.0 times 10 to the power 6. So this is the third one using factors that I wanted to show you. Okay, so that's why I brought it again. So now I've shown you 3 ways. The first one is the board mass way and moving the zeros and getting the numbers and subtracting. Okay, 2.3 million minus 300,000 straight away and then converting it back. The second one is first to change the 10 to the power 6 to 10 to the power 5 and then subtracting the integers and then adding back and then converting to your standard form. And then the third one is first of all changing the powers to the same so that you can have the integers on its own. Okay, and then now that you have 10 to the power 5 into bracket 20, you can add the 0 back and then convert. Okay, whichever way you do it, these questions, they are maybe like a mark or two. Okay, but if a question like this comes, it's fairly easy, so you can strive to get that mark. You can do it. So I was thinking about it, and I thought I can easily show you this method as well, okay, so that maybe it will be easier. The three methods, I don't know which one, but whichever one you go by, just learn it, because if it's not even these figures, then they give you a similar question. You don't want to let it go. You want to get the marks, okay? And that is the purpose of all this platform, to give you tips so that it can boost your confidence. That when you go and sit behind your paper, you can give it the best shot and get it once and just move on and do something with it. Okay. Now we've been doing histogram. So today we'll get back to our topic on histogram. Okay. On a graph paper, draw a histogram of distance walked by a local group using the table given. Okay. Now, in this question, I was given I've given you the table, I've completed it. So the table is here. Okay, the distance walked. Some 40 people walked up to 1 mile. Another 27 walked between 1 to 2 miles. Okay, depending on your strength. Okay, so 0 miles means you can just walk up the road and back. Maybe you can't do anymore. Maybe you're a beginner, and you are just striving to get into a routine and just pushing yourself. So yeah, so that is the 40 people. 1 to 2 miles is like, okay, they've been doing it a while, so some can manage 2 miles, some can manage a mile or a little above a mile, so they came under that. 2 to 5 miles, these people have really been doing it every week, so they are good at it. 5 to 7 miles, wow, 58 of them. 7 to 10 miles, 24 of them. Okay, so maybe they've done it a long time and they can do it. So that is that group. But this is the table. But if you look at the table properly, okay, I have the distance, I have the frequency. Look, it's 2 to 5 miles. I don't have equal intervals. If I had equal intervals, like maybe 1 to 2, 2 to 3, 1 to 2, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, then I might consider plotting an ogive or cumulative frequency curve. But I don't have that, even though I know the frequency of this group. So now I'll look at plotting a bar chart or a cumulative histogram. But with a bar chart, I also need equal intervals. So the only option here is to plot a histogram. And this is where the frequency density comes in. Okay, so the class width here is the difference. So the distance in miles, the class width will be 1. 1 to 2, the class width again will be 1. 2 to 5, the class width will be 3. Okay. 5 to 7, 2, 7 to 10, 3. Okay, the intervals are not the same. So to plot the histogram, I need to divide the frequency by the class weight to get another column called the frequency density. Okay, so 40 divided by 1 is 40. 27 divided by 1 is 27. 96 divided by 3 is 32. 58 divided by 2 is 29. 24 divided by 3 is 8. So now, instead of the cumulative frequency where you add that, now you need to look the class weight to divide. Okay, immediately you do that, then you can do a histogram. So now on your x-axis, you need the frequency density, and then on your y-axis, you plot your class weight. Okay, so yesterday, this is what time could allow us, and then I did I showed you, I used the data to plot a histogram for you. Okay, so this is where we were yesterday. Now I want to make a few comments. No, this table here, we don't have equal intervals, therefore we cannot plot a cumulative frequency curve. That is the ogive. Okay, another name for cumulative frequency curve is the ogive. So the best option is histogram, which I'll show you your graph using this data. Okay, assuming you were given a histogram and asked to deduce the number that worked that weekend, how will you deduce that? So this is another part I will show you. Okay, so now let's look at the histogram we could do. So that is the table there. That is the table. Okay, I'm pausing a little bit, and that is my histogram. Okay, so I'm quickly going to show you how I did it, because yesterday I showed you, so it won't be long. Okay, so this is the graph I managed to do for you today. Okay, so on the x-axis, you have the distance in miles. Okay, and that is the class weight. And if you look at the this thing, it's up to the class weight is up to 10 here. Okay, so my x-axis is up to 10. Okay, the distance is mile is up to 10. So on my x-axis, I have up to 10. Now on the y-axis, which is my density, frequency density, the highest value is 40 here. So again, on the y-axis here, I labeled it up to 45. That is my frequency density. So the first one, the class width is 1, and the frequency density is 40. Okay, so between 0 and 1, the frequency density is 40. So I draw my bar. Okay, histograms are the bars are together. Bar charts, there is a gap. The bars are not together. Then the second one, 1 to 2 miles, the frequency density is 27. So 1 to 2 miles, I have 27. Okay, we've said that use a scale, you understand. So from here to here is 25. So 2 boxes, 26, 27. So that's 27. The third one, between 2 to 5 miles, my frequency density is 32. So that is 30 here. Okay, so 30 is here. Okay, so 31, 32. On the y-axis, each step is so 26, 31 here, 32. So we've done this one. Okay, the fourth one, 5 to 7, our frequency density is 29. Okay, so 29 there. So 25, okay, that's 30. So we need 2 boxes down. So that's 29. And then the last one, 7 to 10, our frequency density is 8. So that's 5. Okay, that's 10. Okay, so 9, 8. So that is where I put my 8. That is my 8. So that is my histogram. I have a title, a graph of frequency density against distance in miles. Okay, and then I have my axis. I've labeled my dates. I've labeled my dates here. Okay, to reference if I have to use this table to help somebody. Okay, now, so this is how my frequency table will look like. Let me see if I can come all the way up for you to see. Okay, so that is how the graph looks like. Okay, I'll pause a bit to capture the graph. And that is how my table looks like. Okay, so I use the class width against the class width, that one, against the frequency table to get the graph. Now, assuming you were given the histogram, so assuming in an exam, you got, now we are talking about the interpretations, okay, you got this graph in your exam, and then you were asked how many people took part, because you've not been told, okay. So, assuming you were given the histogram and asked to deduce the number that worked that weekend, how would you deduce it from the graph? So I'm going to quickly show you that. Okay. Now, from the graph, okay, frequency density times class width equals frequency. Okay, so the first bar, you have a frequency density of 40, okay, times 1. So that would be 40 people that took it. Okay. The second bar, a frequency density of 27 times 1. 27. Okay. So now here you have the charts, but you don't have the table, because I've completed the table, but this chart, assuming it didn't come with a table, how would you know how many people? Because when we look at yesterday's question, we're given the number, and all our archive, they will say 100 and this, 100 people, 120 people, 180 students. So now you've given a chart and they've told you this is what the chart is about, and they're asking you to find how many people took that. Okay, so this is how you go about it. Now, bar 3, you have a class width of 3 times the height of the frequency table, the bar chart, which is 96. The fourth bar, okay, you have a class width of 2. The height on the frequency table is 29, giving you 58. The fifth bar, you have a class width of 3, and then the height, the cumulative density, okay, is 8, which will give you 24. So you add all of them up, and you have 245 people. So if you add bar 1, bar 2, 3, 4, 5, you are going to get that will give you the frequency using this formula here, the same formula that you use to find the frequency density. You can swap, because frequency density equals frequency divided by the class width. So if you were given the histogram, then you can do frequency density times the class width, which is the y and the x axis multiplied together, and that will be your frequency. So I've done each bar, and then 40, 27, 96, 58, and 24. And when you add all of them together, you have 245 people. Okay, so you can use your histogram to find the number of people who took part in an experiment, or who took part in an activity, or who are part of something that is they do, okay, but and you that is how you can use the histogram to deduce that. Okay, so today's work, I came to show you that. Okay, so if you got the table, you can plot the graph, and then if they ask you how many people took part in the exercise, that is how you find it. Okay, so our time is far gone. I've brought back the starter that we did, and I've added third method. Go and look at it. See which one is easier for you to understand quicker, and stick to it, so that if you get similar questions like that, you can do it that way. Okay, but even if you knew the 3 and a complex question comes, you can just look at it and say, well, I'll go by this method. Okay, it's like having so many tools for one job, and all the tools can do the same job. So you go for the one that will make it easier for you. Okay, so thank you very much. Please subscribe. Thank you for subscribing, liking, sharing, and following our platform. Okay, and thank you very much for watching my video today, and I'll see you in the next